We are going to go through how the quadratic formula was developed. The quadratic formula is a formula that we use to solve quadratic equations when they're written in their standard form. So we know our standard form looks like this, and when we solve a quadratic equation, solving it would be like finding the x-intercepts for this parabola. And when you find x-intercepts, we're really letting y equal 0. The coefficient of the x squared is called, or is labeled a. The coefficient of the x term is the b, and the coefficient that is a constant is our c, and that's our y-intercept. So what we're starting with is this form, where we have the y equaling 0 for our x-intercepts, and then we're following our steps for completing the square and writing this as a perfect square, like we were doing yesterday. But this time it's in generic form, so I don't actually have numbers in here, I just have letters. But we know step 1 would be to factor the a out of the x squared and the bx term. Okay, so that's step 1. So that's what's happening from here to here. We're factoring a out of the x squared and x terms. And then what we do to complete our square next, to go from that line, the second line to the third line, is we take half of the b over a, we take half of this new b term, and then we square it. So if we take b over a and divide by 2 to take half of it, that's the same thing as b over a times 1/2, which is equal to b over 2a. So that's where the b over 2a is coming from. And then we need to square that term, so that's why we have a square here. Now we add that value and we subtract that value. So that's the second step. Then, to go from here, we know that we need to move this term outside of the bracket because these three first terms form that perfect square. So we're going to multiply the a with this term and move it outside the bracket. So that's what we've done. We've kept this piece in the brackets, so this piece in the brackets, and then we're multiplying the a with this. So we've got the minus from here, the a times the b over 2a squared. So that's been moved out of the bracket. The next step to go from here to here is we're writing this in its factored form. So we're taking the square root of the x, putting it here, take your sign from the middle, and we square root this last part. So if we have b over 2a all to the exponent of 2, when I square root that, I get b over 2a. So that's this part in factored form, written here. And then I've just copied this other piece down, except I've expanded or squared this term here. So if I have b over 2a squared, b over 2a squared, that's going to equal b squared over, and then I've got 2a times 2a, I've got to square that, and that gives us 4a squared. So that's what I have written right here, b squared over 4a squared. Now, on our next line, what I have done is I've actually simplified the a with the a squared. I've got one factor of a on the top here, and I've got two factors of a on the bottom. So a to the 1 on the top reduces with one of these a's on the bottom, leaving me with just an a, one a on the bottom. Well, 4 times a to the 1 on the bottom. Okay, so these a's reduced, leaving me with just one factor of a on the bottom. Okay, everything else has stayed the same to go from that line to that line. On the next line, what I'm doing is I want to be able to combine these last two terms. So what I'm getting is a common denominator. Now this has a denominator of 4a, so I want this denominator to become 4a. But in order to do that, I also need to times the top by 4a. And when I get there is I get 4ac on the top and a 1 times 4a, or just 4a on the bottom. Now I can collect these. When I'm adding fractions, I'm going to just add the numerators together and keep the denominator the same. Before I do that, though, what I'm going to do is factor out a -1 out of these two terms here. So I'm taking -1 out. We don't usually write the 1 in. And that's going to switch the sign of this one. And in doing so, now I can do a b squared minus 4ac on the top and have one denominator of 4a. Everything else over here has stayed the same. Nothing has changed. All right, from there, I have a minus this thing, which is just a number, a term. To undo that, we're going to start now isolating. This really is our vertex form. So this is our vertex form of the parabola. Vertex form. What I want you to notice here before I go through the solving, do you see that this piece would be the x-coordinate of our vertex? We could write that as x take away and then a negative b over 2a. The x-coordinate of our vertex could be obtained by doing negative b over 2a from our standard form. So if I had an equation with actual numbers in here, let's say I had y equals 3x squared minus 4x plus 1. The a value is 3, the b value is negative 4, and the c is 1. I can take those values and put them into this little formula here, and I know from this, the x-coordinate of the vertex would be negative b, so negative, b is negative 4, so negative the b divided by 2 times the a, and the a was 3. So the x-coordinate of my vertex for this parabola, without having to do a whole lot of work, actually could be just written as 4 over 6, which is 2/3. So it's kind of a cool little trick that we know. Okay, and then this piece here would be the y-coordinate of the vertex, but it's pretty complicated. So once you get the x-coordinate of your vertex, we know we can just sub it into the equation to solve for y, and that's quicker or easier than using this mess of stuff here. All right, now what we're doing is we're isolating for our zeros. So I have a subtract this thing. I'm going to undo that by adding it to both sides. So it's going to undo it on this side. It comes over here. It becomes a plus and this thing. Okay, so it's a positive this thing. At this point, I'm starting to isolate. The next step would be to divide by the a. So if I have my b squared minus 4ac over 4a squared, and I divide by a, that's the same thing as multiplying that by 1 over a. So multiply by 1, divide by a, multiply by 1 over a. Okay, and I miscopied what I had. I was trying to figure out what I was doing here. I miscopied. That should just be a 4a over here. Okay, so I'm taking this thing that I have here and I'm dividing it by a. And when I divide that by a, I'm going to times by 1 over a, and that gives me my b squared minus 4ac over 4a squared. So that's where this a squared is coming from to go from this line to this line. I'm dividing it both sides by a. Okay. Now, to undo the square, we square root both sides, and when we do, we've got two answers, the positive and the negative, and I'm square rooting the entire thing, so that square root goes right down to the bottom. One of the rules for square roots is with fractions is that's going to be equivalent to the square root of the numerator divided by the square root of the denominator. And the reason I broke that up is I can actually square root 4a squared and get a nice answer of 2a there. Okay, so that's where that has come from, just simplifying this side. Nothing on this side has changed further. And then I'm going to undo this plus b over 2a by subtracting b over 2a. So I have this, and then I subtract b over 2a, subtract b over 2a, and I have my plus or minus already there. Okay, so that's my minus. Now I have a common denominator already, so I could rewrite that as one term of negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that is our quadratic formula right here. So that's our quadratic formula. So if I had this equation of y equals 3x squared minus 4x plus 1, if I have that equation and I want to find the x-intercepts, instead of completing the square on this thing to get it into vertex form and then solving for the x, I could just use this formula. My a value is 3, the b is negative 4, and my c is 1. My x will equal negative b plus or minus square root b squared minus 4ac, all divided by 2a. Okay, and then we just evaluate it from there. So that's going to give me a positive 4, a negative 4 is a positive 4, plus or minus the square root of negative 4 to the exponent 2 is positive 16, and then we've got a minus 12, all divided by 2 times 3 is 6. Let me move this way up here. We're going to get x being equal to 4 plus or minus the square root of 4, all divided by 6. 4 plus or minus, now square root of 4 is a 2. These don't always work out to nice integer answers. I've just made this one so it would. So my two x values will be x equals 4 plus 2 over 6, or x equals 4 minus 2, all divided by 6. And it's important that you actually get the sum here. Hit equals, get the sum, and then divide by 6. So we get 6 over 6, which is 1. This would be a 2. 4 take away 2 is 2 over 6, which is 1/3. So this one would have been one that could have factored, and we could have set the factors equal to 0. But the quadratic formula works as well.